Right, we're going to be looking at how physical processes combine to create physical landscapes, basically how the weather can give us cliffs. We're also going to be looking at how the weather and the cliffs combine to make settlements in the upland areas of Great Britain small. Okay, we're going to look a little bit today at Ordnance Survey maps, figuring out how they show both the physical and the human consequences of this weathering and stuff. So at the end of this clip, please make sure you can explain all the words in blue and how they can interact. Let's go. He says, pressing the button. Right, weathering. Weathering is not erosion. Weathering happens in situation, in where it is. We do not need movement for weathering. So, excuse me, what we're going to be looking at is what weathering is in the uplands. And in particular, we're going to be looking at freeze, thaw. The examiner wants you to know about the climate. So let's just go through where we are on planet Earth. Our uplands are around about 50 degrees north of the equator. I've drawn a line that is also 50 degrees north of the equator. Now, if you head over to the North America, over to our west, that line is incredibly far north when you think of where the Great Lakes are. That's the border between America and Canada. That is frozen all winter. We are north of that. If you head over to the east, in the continent there, in Russia, it's so cold. You breathe out on a cold day. You see your voice, your breath condense in front of you, then you see it freeze and fall to the floor. It is that cold. So we don't get that cold. And that is one thing that you've got to remember in terms of freeze thawing. Let's have a look at a climate graph. Now, forget the blue lines for a moment, okay? The blue lines are the rainfall, the precipitation, but do look at the red line. The red line is the temperature. Now, what we want, my head's sort of in the way, but what we want is the axis on this side, so the y-axis, but over on the left-hand side. I'd prefer you to use degrees C. You can see, hopefully, that month 1, 2, 3, and certainly 11 and 12, the red line is below 0. Okay, so if you're a bit of water and it's November, you freeze in November, you stay frozen in December, you stay frozen in January, February, March, and it's only in April, May that you actually thaw. Let's now have a look at the United Kingdom. This is a climate graph from the Lake Districts in the uplands. Forget the blue again, just look at the red. The red is the temperature. You can hopefully see that not once, again, we're looking at the left-hand Y column, not once is it below 0. Please remember, though, that is an average temperature. So what's happening in the United Kingdom is at night, when it's close to 0, it's probably dipping below 0. So January and February, it's quite cold. At night, it's probably going to go below 0. Then look again, month 11, 12, November, December, pretty much guaranteed to be below 0 at night. So for those 4, maybe 5 months a year in the Lake District, the water freezes during the night, melts during the day, freezes during the night, melts during the day. Freeze, thaw. Whereas over in Canada, we've just seen that it's going to freeze in November and stay frozen the whole time. Now, why is that important? These are the lines that sort of show me. Well, it's important because freeze, thaw, we need the thawing for the freezing. Let's just quickly explain why. Why aren't we that cold? Well, we've got this thing called the Gulf Stream. Our weather mainly comes from the southwest and all the way over in the Gulf of Mexico area. The water is heated, the air is heated, it expands, it moves away from the heat source, which would be the equator, so it drifts north. Now, planet Earth is spinning, the Coriolis effect makes it look like it's drifting over to the east, and it basically hits Western Europe. So we're quite fortunate that we don't get these very, very cold winters, but it also keeps us pretty mild during summer too, and is why we have so much rainfall. So let's now look at freeze thawing, and here is a photo the examiner might give you. It's a scree field. It's evidence of rapid mass movement or rockfall. Okay, and the examiner is quite keen that you should talk about rockfall. rapid mass movement. So let's have a little look. We've got a crack in the rock. The crack fills with water, precipitation. The sun goes down. It's cold at night. Sorry about that. The water freezes. Water gets bigger, increases 10%, expands 10% when frozen. So that night, the water has made the crack larger. Okay, now this is the important bit. The sun comes back up, the water now returns to liquid, it thaws, and so now the crack is actually bigger, and the next time it rains, it can fill up with more water. That then expands by 10%, repeated action over time. Your rockfall. So how does that give us cliffs or sheep? Nighttime. Okay, so that gives us scree fields, especially if the rock that's making the cliff that is being weathered is, let's say, slate. It can give you boulder fields if the rock's more massive, there's less bedding lines in it, maybe like a schist. So remember those rocks that we talked about last lesson. What does that look like in an Ordnance Survey map? Well, let's zoom in a little bit. The orange lines are contours. Hopefully you can remember that. Now, even my eyesight can see 100 and something like 700 and plenty. So look, there's the 100. There I've got 740. Now, remember the grid, the blue straight lines are 1 kilometre apart. That means basically in about 1.5 kilometres, that land is going from 100 meters above sea level to nearly 800 meters above sea level, more than a 600-meter rise in less than 1.5 kilometers. So it's incredibly steep, okay? If you see on the contours little black lines that look a little bit like cliff outcrops, that's exactly what they are. So on an OS map, that is a classic example that you've got a cliff, you've probably got scree at the bottom, and it's an incredibly steep slope. Now, right next to that steep slope is an area where there's no contour lines at all. If I look at that circle just to the north by that place where it says Fogmere, you've got 100 meters above sea level. Just over by the star again, you've got another contour that says 100 meters above sea level. So it's dead flat there in that space. So we've got a very flat valley bottom, very steep cliff. Other side, you've got your U-shaped valley. Okay, that is classic U-shaped valley uplands on a contour map. Right, the next idea with climatology and also freeze-thaw is rainfall. We don't just need the water freezing and thawing and freezing and thawing. We need more rain to go in every time that the crack is opened up. So, relief rain. Water evaporates from the sea, condensates into clouds, but is still as vapor. We've got this Gulf Stream giving us our wind and our weather. Now the cloud rises. As it rises, it cools. As it cools, the vapor precipitates back into liquid and lands as rain. Okay, so that's relief rainfall. What does that look like over the entire country? You get our front coming in, pushed over the uplands, and then poodles on over to the lowlands where it isn't raining. So what does that look like on a climate graph? Well, this time the Lake District's on the left-hand side. This time we're not bothering with the red line, we're just looking at the blue lines. Blue line precipitation, blue line the units on the right-hand side of the y-axis, and you can see that it's going on the Lake Districts 25, 50, 75, 100, 125. Now, the climate graph over on the right is Essex, Clacton on the Sea, slightly different scale, but we're still looking at the right-hand Y millimeters, where it's going 15, 30, 45, 50. Now, I've put a little line where the 50 would be, check and have a look at that. If we go to the uplands, every month of the year, it averages more than 15 millimeters of rainfall a year. Go further on, 1, 2, 3, 4, 5, 6 months of the year, it averages more than 100 millimeters of rainfall a year. Going over to Essex, you've got 3, maybe 4 months of the year where it's just about 50, and only once does it get up to 60. It is never averaging more than 60 millimeters of rainfall a year. So you can see how different the climate is in the uplands than the lowlands. Now we're zooming in on the uplands. How does it affect humans in the uplands? This graph shows you it really is much wetter. So chloropeth, darker the shade, the higher the unit. This could be an exam, a chloropeth map. How does that affect humans? Well, there's not much farming can go on in terms of crops. 1, the summer's very short. 2, it could be quite cold. 3, it rains so much. So even in the flat valley bottom, where you could possibly get a combine harvester to work, you can see it's wet, so crops would rot. So in the uplands, the farmers has to be pastoral. They'll have sheep, they might have cows. What do they do? Well, in the summer, the sheep go up into the hills, they graze on the grass that's growing there. In the winter, they're brought back down into the valley bottoms and put into barns. What else can farmers do? Well, you've got all this stone and scree left over from the rockfall, so they need to clear that up to make the fields, but also they can use that to make their fields, right? So you get dry stone walls. The rocks will be used in their villages, but the villages won't get big in the uplands. 1, because they're sandwiched in between valleys, and 2, because people tend to go to places where there's well-paid and interesting jobs. There aren't that many interesting, well-paid and interesting jobs in the uplands. I'm very sorry about that if you live in the uplands. Also, communications are quite slow. It's difficult to get big motorways built in where it's really, really steep. And even if your village and the next door village are quite close to each other, if there's a big mountain in the way, a big fell in the way, you have to go all the way around the U-shaped valley. So communications are a problem. So what other industries are there in the uplands? Well, one industry the examiner wants you to recognise, particularly on a map, is the Forestry Commission. After World War I, this country chopped down an awful lot of trees because wood was needed in the trenches during World War I, all the wooden platforms and support beams. So World War I, the Forestry Commission was started after it, and if you ever see a map like this, and they're talking about physical human geography at the same time, have a look at the very sort of southern bit down there. Can you see that all those trees look a little bit like Christmas trees? They're conifers. So the Forestry Commission has planted that area. Okay, let's combine a little bit of physical and human. You can see that that little village is stuck in a very, very small flat area. It can't grow up those sided cliffs. They'd be way, way too steep. And you can see that the road here is a small road. Have a look, it's sandwiched there in a V-shaped valley right against the river. So I'm hoping this has been useful to you guys. Please make sure every single word on the clip there you can sort of use and explain, and have a look at the overall question, see if you can answer that in good detail. I'm hoping this has been useful.